Walk me through how you, Nick, help.
1250 squared equals 200 squared plus run squared.
Okay, so here's your run, which we don't know yet. Let's use colors. So using that bad boy over there, your hypotenuse 1250 is going to be equal to this guy squared plus that rise squared. It's okay with you guys, I'm dropping the unit for right now. The unit's just kind of getting in the way. Realize that when we're done, the unit is going to be meters. Right now, it's square meters. That gets interesting. Whatever this is, whatever that is, 40,000 square meters. That doesn't really mean a whole lot. It's an intermediate step. Okay? So go ahead.
So why wouldn't the rise be the 200?
It is. Oh! I switched these two. Let me do this.
Oh.
It doesn't matter. Why is it okay to switch these two?
Oh, I'm sorry. No, I was confused. I actually did the rise.
It doesn't matter which one you put where. Why?
Okay.
Good. What's the property that we just invoked there? It's a French word. Starts with C. Micah? Commutative. Swishable. Doesn't matter. Now, certain things do matter mathematically. If there was multiplication and addition, that would matter greatly. But this does not. It's just addition. You can add in any order you want to. And you're about to see why. Rather than multiplying these out right now, I'm going to solve for the run squared first. This is what you guys were doing in your calculators as I looked at your work. So I'm going to move this guy over to this side. 1250 squared minus 200 squared is equal to the run squared. This is kind of like your project that you turned in today. You're moving that number over to the side. That's all you're doing. That's all you're doing. Fair enough? Good. And I'm going to get rid of that squared by taking the square root. Now, as I watched what all of you guys did with your calculators, you did it step by step and it was perfect. So when these guys were crunching through their calculators, the first thing they did was they did this, then took the square root of that. Now, that's awesome, and I think everybody will do that if left to their devices and their calculators, and that's fantastic. The problem exists in symbolically, we don't always see what we have to do. We have to take the square root of both of these things, correct? We have to take the square root of both of those things. The kicker is, over here, that equals just the run. On this side, it equals the square root of 1,250 squared minus 200 squared. You don't knock the squares off with the radical. And there's a reason for that. Who knows why? Say that again. That ruins everything for us. Yeah. There are parentheses around that operation. You don't see them. But have you ever noticed when you press the square root button on your calculator, what symbol comes with it? A left parentheses. That was one of the greatest things TI ever did. For years, they didn't do that. When you press the square root button, it just had a square root. You had to put the parentheses in. And this is one of those things why I can't stand please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. It needs a whole bunch of other P's. It needs an FB, and it needs, what else does it need? It needs an FB, it needs a DS, it needs another P, because there's other symbols that imply parentheses, but you don't see the parentheses, and the radicals are the biggest one. When you hit a square root, there is a left parentheses there, and the operation under there has to be done before taking the square root. Does you see what I'm getting at there, friends? Now you guys, when you did it sequentially, you took care of that, because you did the operation inside first, and then took the square root, and you were happy. So, when we do all this, what's the run end up being, friends? 1,234 meters. Back to our triangle. Just bring this back over here. Back to our triangle. Let's back up a little bit more. Okay. Wow, 1, 2, 3, 4. Is that nice? Which means the technically correct way of doing the grade. Now, here's where I need your machines to help me. Here's where I need your machines. This isn't good enough anymore. Because I'm going to approximate that as 16% too. It's damn close, isn't it? It's damn close.
It's
It's the same percentage. I need more decimals though. Can you give me a few more decimals? So quick, everybody go back to this one again. And give me like 3 or 4 decimal places. Andrew, you got it?
Yeah, it's 162074.
16207. I'll call that 1621. If that's okay. Just right up to 4. Anything past 4 decimals is getting a little ridiculous because it assumes that we have ridiculous accuracy in my meter measurements. And you got to remember something. We pulled those meter measurements as approximations off my graph. In order to get more precision, I'd have to go back to my raw data and look at the GPS coordinates. See, everything we're doing is off of these approximations that we get, right? See what I'm saying now? Your data is only as good as our eyeballing the graph. Okay, Andrew, if you would, what is 200 over the 1, 2, 3, 4 meters?
It's the same thing.
It's the same 4 to 4 decimals?
Yeah.
Holy crap, give me more then. Now I'm curious. What was it, 1620?
74554.
This is ridiculous. Please, I want to apologize to the YouTube world and you. This is a ludicrous number to even write this many decimals out for. But I'm just curious to see how close our other one was. What's this one here? .1620.
Well, actually, that one was.
1621?
No, that one is
No,
the other one that
That
you
was
have.
the other one.
Oh, this is this one. Okay. 074554.
Yes.
What's this one then?
Just 16. Yes.
1620.
No, there's no, it's just point
We
one
ran
six.
it 221. It's pretty much the same thing. Yeah.
It's exactly .16?
Yes.
Holy crap! So my ballpark was exact? Everybody see that? I want to brag.
Yeah, all
So, here, now I feel better. That makes me a little bit happier that it's close, but it wasn't close to the 10,000th place. Okay, here is my point. Here is my point. My point is that that is wrong. Technically, it's wrong, isn't it? Because we didn't do rise over run, we did rise over hypotenuse. This is correct. But my question is, how far off were we by doing it wrong?
Not very.
Not very! And here's why. That triangle is drawn awfully. Friends, if this is 1.25 kilometers, how the hell can that be 200 meters? Right? This is almost as big as this. It should be 1/6 of it, shouldn't it? Yeah? There's only a difference, what is it, 16 meters? What's that, 50 feet-ish? There's only a difference of 50 feet. But now, why are we bringing this up? Why are we even talking? I think I mentioned this somewhere in one of the homework questions is how far off? Oh, do I have you do a percent error somewhere back there? Yeah. You can actually calculate the percent error in our estimate. Let's do that too. What the hell? I'm not sure if it's here, but let's do it. How far off are we? So here's the question. How far off are we now? I'm starting to, in my mind, I'm developing a take-home question for you guys right now, doing this kind of stuff. This is going to be good. This is going to be good. Like doing the Mackenzie pass ride the wrong way, then do one of them the right way and do the percent error. You're getting like 1/3 of your exam in my head right now. This is good. This is good. This is good. So, good. Let's do it. Let's do it. So here's this triangle. I'm going to take this out. I don't need it anymore. So let's say, what is the percent error of our estimate, of our incorrect estimate? Now I'm calling it incorrect. I'm calling it incorrect because the way we did it originally was wrong. We treated the hypotenuse like it was the run. But it's not. It's not the run. It's the hypotenuse. But the question is, okay, it's wrong. It was also easier to do, wasn't it? We didn't have to bust out Pythagoras because Pythagoras only exists to get us the run. So if we treat that as the incorrect and see how off it is, well, the way you do percent error, if you ever need a formula for it, just so you know, if you look at the homework, you can find it. And I'm gonna hit this a lot in this class, just so you know. Grade somewhere down here. Oops, did that open for me?
It's like east.
There's Nicolas Cage. There it is. Where was it? I went right by it, didn't I? There it is. Percent error. Amount used incorrectly, correct amount, blah, blah, blah. So if you ever need the formula, I will always give it to you, just so you know. But if you're sitting at home and you forget what the percent error formula is, it's in almost every homework assignment because I like it so much. I like using it an awful lot. Because it gives us an idea of mitigating of mitigating exactly how off we are in our estimates. And that's the beauty of it. That's the beauty of it. We can measure how far off we are. So we're going to use it. I just want to let you know, you guys, it's there. It's there waiting for you if you need it. So, we're going to go with the incorrect estimate. Minus the correct one. All over the correct one. And let's break down the formula just to make sure we understand why it works. What do you get when you subtract the incorrect estimate from the correct one? The difference between them. Awesome. Awesome. And we are going to be off in this point by 0.02% or 2/100ths of a decimal, I guess, a tenth of a, 2,000ths, thank you, 2,000ths of a decimal or 0.2 of 1%. And that is small. But you got to remember, we're taking that's percentage points, not necessarily just a unit list. That's now in percent. I want to know a scale across the estimate itself. How small is that? And that's where it gets really, really microscopic. So, our incorrect estimate was 0.16. Are you sure it was exactly 0.16?
Yeah.
It's mind boggling.
So when we're doing it, would we put all those numbers in, or do we?
There weren't, no, just call, you technically yes, but call it 0.162, that's totally fine. Yeah, Linda's asking a very good question. Did you see how nervous I got when I started writing all those numbers out and I said, oh God, this is ludicrous writing this many numbers down? Because you have to think about why. To be able to measure out that far, every single decimal place that you add to a calculation means your measurement instrument has to be 10 times more precise than the previous one. That is ludicrous to think about. It's the same reason I always laugh when people recite values of pi. 3.1415, blah, blah, blah. You can stop at 5, because anything past 5 is not making a wheel any rounder, or that can any rounder, or anything, that lens up in that camera any rounder. I mean, if you get a couple more decimal places, you might get the Hubble Space Telescope to not be out of focus, or the Mars lander to land correctly. But I mean, when you're reciting 10 decimals of pi, that's ludicrous. A millionth place of accuracy? Unless you're working for NASA, you're not getting that kind of accuracy. So Linda, 0.162 is totally fine. Okay, 0.162, that goes here. And that 0.162 is also the correct estimate, it goes down here.
So don't they just cancel each other out and we're still left with being incorrect?
Oh,
I mean, what happened there?
Whoa. I just got a little bit of,
Could it be the minus? That's
The
what-
I got some itches over here. I'm itching. Right, you gotta remember, and this is why I can't stand, please excuse my damn Aunt Sally.
Right.
Here's why. There's a fraction, remember how I said, please excuse my dear Aunt Sally means an FB in it? What does FB stand for? Fraction, clear your minds now. Keep the G-rated in here. Fraction bar. You don't see it, but that has to be done first. You don't see that, but that has to be calculated first. I love what you said, Di. I love what you said about canceling the 0.162 and the 0.162. But think about why you can't do that.
Well, you don't get the right answer.
Well, okay, but yes, but think about why you can't do that, not why you shouldn't. Or at least why you shouldn't. Kirsten, go ahead. If you do that, and you replace them both with 1, which you would do if you cancel, it's actually dividing a common factor, you then exacerbate how large these two things are. You made them 6 times bigger than they should be, but you haven't changed that scale at all. That's one problem. The other problem is, when you cancel, you're dividing out common factors. These aren't factors. They're terms, because they're separated by subtraction. If that were a multiplication symbol, cancel away. Because then everything's on the same level of order of operations. But it's interrupted, just like it was over there with the minus sign, by the order of operations of plus and minus happening after multiplication and division, but have to happen before because of the implied parentheses. I spent 2 weeks at Math 95 harping on this, when I used to teach Math 95. Because people still, after 3 terms, 4 terms of algebra, think you can cancel, and you can, but not every time. Does that make sense? Fair. Okay, good. So now, I think we're ready. We now have, what is it, negative 0.002 over 0.162, which ends up being, go ahead,
0.0123.
0.123.
No, there's.
One less zero?
Yeah, one.
One less zero, which is important. We are 10 times more in error that way.
There we go.
There we go. 1, 2, 3, I like that too. So, why is it negative?
Well, actually, it goes 1, 2, 3, 4, 5, 6, 7, 8. Not actually. Skips 8. Goes
Are you kidding me? Jesus. This day is a little much for me, I'm not going to lie to you. It's a little too much.
Best part is it's being recorded.
It's being recorded! Why is it negative?
Because the,
Yeah.
go ahead.
Well, it's like negative 0.002, because if you divide negative, it'll still be negative.
Absolutely, mathematically, we're dividing negative by a positive. What does it mean about our original incorrect estimate? It was too, Joe, go ahead. It was too low. If our error is negative, that means we came in under the true value. If it was positive, we'd be above it. If it was right at 0, we'd be right at 0. So what this is this is a percentage. We were under by just about 1%. 1% error. Let me share something with you guys, because this is the kind of thing that is not common knowledge in algebra class. Being off by 1% is freaking amazing. If you're in error by 1% on most things in your life, you are well within the realm of totally, like my mortgage payment, I said it was $800. If I was in error by 1%, that means it would have $808. You see what I'm saying? That's negligible. If I'm off by 50%, then we're talking about some issues here. But if I'm off by 1%, that's not that big a deal at all, is it? So think about this. The reason I'm bringing this up, the whole point of this exercise of percent error, as it always will be, is to mitigate how off we are. But my real point here, and I'm seeing where this problem is going to go, I think I have like 3/4 of your take-home exam right now in my head, is this was wrong, correct? Does it matter that it was wrong, or does it get us close enough to where we need to be? That's why. It gets us close enough. All that I wish you could have seen. I should have swung the deflation in the attitudes of liking mathematics in this class. As soon as I drew that triangle on the board and put that Pythagoras' theorem up there on the board, I could just feel the energy go. What this shows us is we don't have to worry about doing that. Now, there are sometimes you do. For example, what angle is that? We have time for this? We do have time for this. What angle is formed by my hill repeat? I know that Nick gave us the answer, I think, earlier, but I want us to figure it out too. And to help us figure it out, if you didn't get a chance to run in your homework, there's a little series of steps that walks you through how to do it with your calculator. And I encourage you to look at that. We can run that at the end of the class if you want to. If you don't want to do it that way, let's do it